Working at height is a major risk factor in building and construction. This presentation will seek to outline some of the measures we take to control this hazard. But first, this is what WorkSafe Victoria has to say.
Falls are the #1 cause of fatalities in the construction industry. Here's how to implement a hierarchy of control to protect you and your workers. First, identify any task that may involve a fall hazard and implement the highest level of safety protection possible. There are 5 safety control levels that can be applied to any worksite that contains a fall risk. Level 1 eliminates the risk of a fall entirely. Working at ground level or on solid construction, using long-handled tools or extension poles for tools. Level 2 requires using fall prevention devices like scaffolding, guard railing, or elevated work platforms. Level 3 combines controls, using work positioning systems like industrial rope access and travel restraint systems. Level 4 doesn't prevent falls, it arrests them, using industrial safety nets, catch platforms, and safety harnesses. Level 5 requires the use of a ladder. You must ensure they are fit for purpose, appropriate for the task's duration, and set up correctly. For all control levels, a safe system of work must be implemented. If the fall risk exceeds 2 metres, a safe work method must be used. And remember, levels 2 through 5 require an emergency procedure to rescue the person and to provide first aid immediately. To protect your workers and yourself, visit WorkSafe/high standards.
Working at height is very much a high-risk construction work activity. Therefore, before Hallmarc or a subcontractor commence any work at height, a SWIMS must be provided and approved. The SWIMS must meet all the criteria as laid out in the Build Pass checklist, including rescue procedures. Handrail and visual barriers are installed for everyone's safety. Anyone adjusting, tampering, or removing these are exposing themselves to removal from site. All handrail is to be installed by a competent person, and a handover certificate provided along with engineering and design drawings. Handrail must then be inspected and signed off weekly as part of the weekly site safety inspection. For this purpose, the Hallmarc site manager will be considered a competent person. In the instance of ceiling works or any works that require platform ladder use within 2 metres of an edge, it is expected that a 5-rail system would be used. Common installation and engineering documents for scope systems, Omniform, and Safety Boot are retained by the HSEQ manager. And remember, any guardrail installed by Hallmarc is subject to the exact same criteria. Elevated work platforms are common and safe when used correctly. EWP uses combined controls against risk. For example, the plant's basket represents an engineering control, the logbook represents an administrative control, and the harness, well, that's PPE. The non-negotiables for EWP are the appropriate license or verification of competency, daily logbook checks and sign-off, in-service equipment, harnesses and PPE where required, safe use and observation of load limits, a safe work method statement, a rescue procedure in place, and spotters as described in the Elevating Work Platforms industry standard. Work at heights using harness and lanyard systems is strictly controlled. A working at height permit must be completed in build pass. Workers must provide evidence of working at height training, as swims must be provided, and anchor points and equipment need to be engineered and certified.
No slack, mate.
Yep.
It's to stop you before you get to the edge.
All right, I'll pull it in.
Better.
Travel restraints stop you before the edge. Search WorkSafe High Standards for more information.
Trenches and excavations can also present a serious fall risk on site. The Hallmarc excavation permit addresses fall hazards. It is the responsibility of the subcontractor to protect their excavation with solid barricades or visual barriers at a minimum of 2 meters from the edge, as well as displaying appropriate warning signage. As the principal contractor, the Hallmarc site manager and all Hallmarc workers should be constantly assessing site for fall hazards. This includes falling objects. With regard to falling objects, kickboards, safety netting, tool lanyards, exclusion zones and more contribute to keeping workers safe.
In 2020, the construction of a 48-storey high-rise apartment building was underway. The principal contractor engaged a subcontractor to install fire protection sprinkler systems for the building. On the day of the incident, workers started the installation of the fire protection sprinkler system on level 26. One worker positioned himself on a scissor lift within 2 metres from the edge of the building to install the sprinkler system on the ceiling. The edge was protected by guard railing approximately 1 metre in height, covered with metal mesh. Perimeter screens were also installed. However, there was a gap of approximately 600 millimetres between the perimeter screen deck and the edge of the building. The worker was installing a steel sprinkler head weighing 400 grams. The worker lost control of the gap between the perimeter screen deck and the edge of the building. It fell approximately 93 metres, striking a truck belonging to civil infrastructure workers. No workers or members of the public were injured. Using the WorkSafe dropped object calculator, the impact of the sprinkler head falling that distance is the same as being hit by a car on the street. Delays in facade panel manufacture meant the facade could not be installed behind the perimeter screens, leaving levels 22 to 25 exposed. To combat this change, the principal contractor organised for the installation of guardrail and vertical debris nets. 1 week prior to the incident, formwork on level 26 was completed. The principal contractor's supervisor signed a handover stating vertical debris nets or perimeter screens were in place with no gaps, rendering it open to other trades. On the day of the incident, there was a gap of approximately 600 millimetres between the perimeter screen deck and the edge of the building. The vertical debris nets had not been installed. The principal contractor's site induction did not include information that work should not commence on levels where vertical debris nets or perimeter screens were not installed. An investigation into the incident identified the principal contractor failed to install covers over gaps and openings between the perimeter screen and building edges. Install vertical debris nets to the perimeter of the building on level 26. Verify risk control measures were in place prior to floor handover to the services trades. Prevent trades, including sprinkler fitters, working on the 20th floor until the vertical debris nets were installed. Provide information to subcontractors to ensure work did not commence on levels where vertical debris netting or perimeter screens were not installed. The subcontractor failed to identify the hazard and control the risk of falling objects before commencing work. Implement risk control measures such as using lanyards to prevent equipment from falling. Ensure vertical debris nets were installed and gaps and openings between the perimeter screen and building edges were covered before starting work. Prevent workers working on the 26th floor until adequate controls were installed. Provide information, instruction and training to workers about the risks of falling objects when working at heights. Falling objects can pose a serious risk to both workers and members of the public. Where there is a risk of objects falling from height, risk such as conduct internal works behind the facade. Design it out of the build. For example, off-site assembly or fabrication to eliminate activities that would otherwise be performed at height. Reduce remaining risk through substitution, isolation or end controls, such as design project-specific perimeter screens to encapsulate the building, ensuring the bottom deck closes the gap around the perimeter of the building. This can be achieved by the installation of hinged timber flaps. Install vertical debris nets, curtain systems, guardrail systems or scaffolding to contain materials around the perimeter of the building to infill any gaps and around edges of internal voids and penetrations. Use rated catch decks for capturing falling objects. Erect overhead protection such as gantries or scaffolds. Risks may be further reduced by administrative controls such as implementing exclusion zones at ground level, storing materials and equipment clear from the edge of the building and internal voids and penetrations. Contain loose items with lanyards, belts and pouches. Restrain materials with ropes, ratchet straps or adequate weights. Introduce a permit to work system. Monitor weather conditions such as high winds. Provide information, instruction and training to employees. Construction workplaces are dynamic and constantly changing environments. If changes to the original work plan or process is needed, ensure the risk controls are reviewed and, if necessary, revised. To help you understand your obligations, guidance material is available on the WorkSafe website www.worksafe.vic.gov.au/falling objects. This video was produced as a result of an enforceable undertaking between Multiplex Constructions Proprietary Limited and WorkSafe Victoria to raise awareness of occupational health and safety.
Ladder use is to be considered a working at height hazard and should be assessed in a SWIMS. A-frame ladders are not to be used on Hallmarc sites. Extension ladder use can be considered for short-term access and use only. Subcontractors must discuss this with the site manager first.
In 2020, the construction of a secondary school building was underway. The principal contractor engaged a subcontractor to provide carpentry services at the site. The subcontractor engaged a contract carpenter to provide labour to install roof trusses. On the day of the incident, workers of the contract carpenter were installing single-span flat roof trusses on erected wall frames. A worker stood on the top plate. A truss was passed up to him by other workers. As he was placing the end of the truss into position, the truss became unstable and the worker fell to the concrete floor slab. The worker suffered serious head injuries. Before the incident, a Safe Work Method Statement, SWIMS, was developed, but it was inadequate because it was not site-specific. It mentioned multiple fall prevention options. It did not specify which fall prevention device needed to be used, and it did not state adequate temporary bracing for trusses. However, the SWIMS did state Workers must not walk on the top plate of external walls, and supervised subcontractor were responsible to ensure the SWMS was followed. On the day of the incident, supervisors of the subcontractor were not present on site. Single noggins were used to temporarily brace the trusses instead of cord ties. Cord ties were part of the manufacturer's instructions and ensure the roof trusses are stable prior to attaching permanent bracing. The truss became unstable due to nailed noggins being used as temporary bracing instead of cord ties. Prior to the truss installation works, an EWP and a mobile scaffold was available on site for use, but were not used. The steps of the job had changed beyond the original plan due to fall prevention devices not being used. At no point did work stop and the SWMS reviewed and revised. Investigation into the incident identified. The subcontractor failed to prepare an adequate site-specific SWMS, stop work and review and revise the SWMS when the work changed, provide fall prevention devices, follow roof truss manufacturer's instructions, supervise employees and subcontractors, and provide employees with information, instruction and training on how to install the roof trusses safely. The contract carpenter failed to follow the SWMS, particularly in relation to not walking on the top plate of external walls. Stop work and review and revise the SWMS when the work changed. Control the risk of a fall. Follow roof truss manufacturer's instructions and provide employees with information, instruction and training on how to install the roof trusses safely. The erection of roof trusses is high-risk construction work, as someone can fall more than 2 metres. When working at height, apply risk controls using the falls hierarchy of control. First, consider alternative designs for large spans and/or high trusses to facilitate safer installation. Next, consider using passive fall prevention devices like a trestle scaffold system, a scaffold on the exterior wall, a mobile scaffold, or an EWP. To further reduce the risk, provide information, instruction, training and supervision to workers to enable them to install the trusses safely, and follow roof truss manufacturer's instructions. Do not stand on or work from the external top plate. SWMS are required for high-risk construction work. When developing a SWMS for truss installation, consider the fall protection to be used, the type of internal platforms and ladders, how to manoeuvre trusses at ground level and at top plate level, how to brace and space the roof trusses to ensure stability. SWMS need to be site-specific and must be reviewed and, if necessary, revised whenever the high-risk construction work changes or there's an indication the risk controls are not working. Falls are one of the leading causes of deaths and injuries in construction. The highest level of risk control should always be implemented. This video was produced as a result of an enforceable undertaking between Tailoring Constructions Proprietary Limited and WorkSafe Victoria to raise occupational health and safety.
Working safely at height is critically important. Falls are one of the leading causes of serious injuries and fatalities in construction. Even a short fall can result in severe harm, including broken bones, head injuries, or death. Following proper safety procedures, such as using fall protection equipment, secure ladders, or scaffolding, and maintaining awareness of surroundings, helps prevent accidents and protects not only the worker but also others below. Prioritizing height safety reduces risks, ensures compliance with regulations, and promotes a culture of responsibility and care in the workplace.